Hi everyone, welcome to
amazing channel of Brilliant Qatar.
When you're rubbing one body with another body, electrons are transferred from one object to what? Another object. Okay, this process, this type of electricity is been given a name.
halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Brilliant Qatar.
Am I audible, guys? You guys can see me. Please confirm. Hi, Haran. Sharmila is here. All right. I should see my peoples. Can I see you people? Gayatri is here. All right. Hi. All right, everyone. Hi, Padma Varshanan. Yes, I can see people. All right. Perfect. Yes. Hi all, let me tell you today's discussion part will be magnetic effect of electric current, and I guess everybody have a very proper idea on the chapter. We're gonna go very precisely and discuss all the different type of questions which came in previous year board paper. So I want you guys to be ready with your pen and paper. Take Pepsi on one side and please be ready. And here I go with my first question, guys. All right. The first question, everyone, the first question is on the screen. The most suitable material for making the core of electromagnet is. So I'm gonna make electromagnet and I have a choice of 4 different type of material. And among those different type of material, I need to just choose one. Help me out with your answer. Let me see what's your answer on the chat box, everybody. And I welcome you in online classes with brilliant group of institution. Yes, C is the answer. Majorities are telling C. Hi everyone, Rishan, hi. All right, that's really good. Really good. All right, let me explain a bit for those who didn't get the answer. Over here is soft iron. Now guys, why it is and soft iron, So you need to go with electromagnetic. How do we make electromagnet? So to do so, we need a solenoid. Everybody knows it, right? So we need a solenoid. In that solenoid, what we gonna place? We'll place a soft iron. And once we do this, right? There you go. I guess you can relate the diagram. What I did made that it's a solenoid where you inserted a soft iron. Clearly visible. In a solenoid, you inserted a soft iron. As soon as I insert this soft iron, what gonna happen? You will tell, sir, it will start magnetizing, right? So here, what is an electromagnet? A magnetic-like material. We often use soft iron, which inserted inside a solenoid. As we do so, it will start magnetizing, everybody. And it is very clear we're using soft iron to make most suitable type of electromagnet. What happens when we use steel? When we steel, guys, still gonna retain magnetism for longer time. However, as soon as I switch it on, this soft iron start behaving like a electromagnet, and when I switch it off, it will demagnetize back to soft iron. So very clear. As soon as the current is on, it becomes electromagnet, and the current is off, it becomes soft iron. So thanks everyone for good comments over here. All right, so we can clearly see now why we are using soft iron, because it has a property of magnetizing and demagnetizing very fast as soon as the current is start and stop. All right, everybody, that's really good. All right, Vishnu sir, the silent king of physics. I love that. I really love that comment. All right, keep going for some more. All right, it's really exciting. All right, when a straight conductor is carrying current, when a straight conductor is carrying current, everybody, when a straight conductor is carrying current. So let me draw it and figure it out what exactly they are talking about. So we have gone through an experiment like that, right? So what we will do here, you will take a straight conductor, all right, a cardboard, you make a hole over here. In this hole, you will insert a thick copper wire in such a way the cardboard should not slide up and down. So if it happens so, so what you're gonna see is, you will sprinkle lots of iron filing over here. So as you sprinkle iron filing, you will gently tap it, and on tapping, you will see they are forming a concentric circle. So those who didn't got me, I'm gonna explain it beautifully one more time and see what exactly it is. Guys, what we will do, first of all, we will take a cardboard. There you go. We took a cardboard. Perfect. We inserted a thick copper wire in such a way the cardboard should not slide up and down. Then you're going to take salt sprinkler, not for food. You will take some iron filings there, and you will gently sprinkle it everywhere. So on doing so, what will happen? Gently start tapping it. You will see this all iron filing will start aligning themselves in this manner. All right, and this is what form? It is in concentric circle. So here I go, in a straight current carrying conductor, the magnetic field will be concentric circle. Perfect. So what is your answer? There is a circular magnetic field line around it. So I guess I'm making sense. If I am, show some fire in the comment box, please. I should see some fires. All right. That's really good. I really love your responses. That's really good. All are responding. Lots of answer. Arpindu is here. Mridul is here. Perfect. Perfectly all right. That's great. That's great. That's great. Let me start with other question. And here you have the next one. Two magnetic field lines. Two magnetic field lines, everybody. Two magnetic field lines. Two magnetic field lines. What happens? They intersect at a neutral point. They don't do this, right? Never intersect with each other. There you go. This is your answer, guys. They never, ever intersect with each other, everyone. So we know two magnetic field gonna never intersect with each other. Why it is so? We know that when this magnetic field, like, let's say we have drawn a bar magnet like that. And what we know about bar magnet, say suppose this is North Pole and this is South Pole. So in a bar magnet, guys, magnetic field start from north to south externally. North to south externally. Internally, you're going to tell, sir, it start from south to north. And the question is, there will be so many lines we can draw, right? And if we draw lots of lines, we know that no two field line going to intersect with each other. This is what intersecting I am telling about. So no two field line will intersect with each other like that. In other words, no two field line will cross with each other. If they do so, everybody, in a point of intersection, the compass will show two directions at once, which is not possible. So what I mean is, like, if it intersects like that, if you place the compass, first of all, let me know about compass. A freely compass always suspend towards north-south direction. Yes or no? Everybody know this? Everybody know this? A freely suspended compass always point towards north-south direction. So there you have, always it point towards north-south direction. And we know if I place the compass in a particular point, suppose I'm placing over here. So what happens? Say suppose this is the magnetic field direction, the compass will start moving towards magnetic field direction. So what I am telling you, get me very clear, okay? Say magnetic field line is going this side. Magnetic field line is going this side, and I am a compass. You carry me and place it over here. I'm gonna turn like that. Understanding? Understanding? Once again, say magnetic field line is going this side. This side magnetic field, it is not visible, right? So it is going this side, we consider. So if I am a compass and I am over here, I can automatically turn like that. There you go. Just like wherever magnetic field line, compass gonna move that side. So that is the point exactly. If I place this compass in this point, of course you're gonna tell compass will show me this direction, right? Right. So one particular compass have a one needle which will show one particular direction. However, if I consider that two magnetic fields are intersecting with each other, what happens if I place the compass in the center? What happens if I place in the center? It have to show two directions at once. Direction number one this side, direction number two this side, which will never ever happen. All right. So you guys got me that clear that no two field line will intersect with each other. If they do so in a point of intersection, it's gonna show two directions at once, which is not possible. Here I go. Two magnetic field lines never intersects with each other. Am I clear? Tell me some yes in the chat box, please. Tell me some yes on the chat box. All right. Sargamne Patel is in the line. All right. That's really good. All right. All right. All right. You guys are getting me. Now, here you go. The next question. Try to answer. What should be the next question? What should be the next question? Try to answer. What should be the next question? Answer, right? I need to see you people. I need to see you people. What should be the next answer over here? All right. Please try to write the answer and I'm gonna call your name. Gaming studio is here. All right. All right. So the question is, which of the following statement is incorrect regarding magnetic field line? Which of the statement is incorrect regarding magnetic? I need to choose an option which is not correct. Get me very clear. I need to choose an option which is not correct, everyone. So to do so, what I will do, I will start reading about magnetic field lines, right? So what is the first part? Tells the direction of magnetic field line at a point is taken to be the direction in which north pole of the magnetic compass moves. Just now I discussed that wherever the field line goes, the magnetic field, the compass will start moving this side, where we have seen here. If the compass goes this side, see, first of all, magnetic field lines are imaginary field line. If magnetic field lines are going this side, how come I assume that the magnetic field lines are going this side? Because I can't see through our naked eye, right? So what I will do, I will take a compass and place in the center. When I place it like this, the compass which is pointing towards north side direction, it will start moving like that. Understanding? So that's what it tells that. The first part, it tells that the direction of the magnetic field at a point is taken to be the direction in which north pole of a compass moves. Of course, it is correct. Let me see the next one. The next one is magnetic field lines are close curve. Guys, we have drawn so many magnetic field lines. Previous part also we have drawn, and we figure out that the magnetic field lines are generally close lines. All right. Perfect. Let me see the D option, which is also correct. So you got the answer which is wrong part, okay? So this is your answer, but before that, let me try figure out number D, why it is correct. Number D, why it is correct. All right. The relative strength of magnetic field is shown by degree of closeness of field line. Guys, we know that the field lines are closer, they are stronger. More the field lines are closer with each other, maximum is the strength of magnetic field, and vice versa. We have seen here at the poles, field lines are at the poles, field lines are closer with each other. And if the field lines are closer with each other, what's gonna happen? You will tell, sir, the magnetic field will increase. All right. However, on the other side, this is other side. However, in the other side, the field lines are having gaps, right? We know a proper diagram of it. I know everybody in the class 10 universe know this, that basically on the other side, field lines are having gap, and because of having gaps, what happens? You're gonna tell me that, sir, this statement is correct. Because of gaps, the field line will be weaker, and if the field lines are closer, magnetic field is stronger. Perfectly all right. It's very beautiful to know the answer is this, and why it is wrong, let me figure out. If the magnetic field lines are parallel and equidistant, they represent zero magnetic field strength. See guys, we know inside a solenoid, where is the solenoid figure? I have drawn somewhere here, no. All right. Let me try making a solenoid and figure out the answer. We know in a solenoid, right? When we draw the solenoid exactly and how we draw the field line inside. So you will see the field line inside in the form of parallel straight line. Yes or no? Yes or no? Yes or no? So field lines are parallel inside, and parallel in the field line represents magnetic field is uniform. 3 points of magnetic field lines, guys. 3 points of magnetic field line. Get me that clear. 3 points of magnetic field line. The first part, if the field lines are closer to each other, magnetic field gonna be very, very stronger. If the field lines are having a gap, magnetic field will be weaker. And this is the third point. If the magnetic field lines are parallel with each other, sorry, I fumble. If the magnetic field lines are parallel with each other, what happens? You will tell, sir, they are uniform. They are uniform. They are uniform. Uniform means equal at all the points. Uniform means equal at all the points. Now see the option. Parallel means they are telling strength is 0. Is it correct? No. This is murder to physics, right? This is a cold-blooded murder. So you're gonna tell me, sir, this is wrong. All right, everyone. I guess you guys are giving some good comments. Let me see. Vishnu sir need magnetism, and that's really good one. All right, all right. Keep going with such comment. See, literally, I'm teaching to end camera. All I can see the comments, right? Perfect, perfect. So let me see the next one. The nature of magnetic field line passing through a center of a current carrying circular loop. This time it is a loop, right? This time it is a loop. This time it is a loop. Try to answer. Try to answer. Recall what was loop. 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 All right. Recall what was loop, everybody. And you gonna tell me, sir, that's how a loop look like, right? Something very scary thing you're gonna see in physics. Like, there you go. Annabelle. Okay, you got this, you have this, and this is positive terminal, this is negative terminal, and what we know, current gonna flow this way, right? Upside, and over here it will be flowing towards downside current. In a loop, it goes up and it comes down like that. Understanding? So when it happens, so you know here it will be a concentric circle, and the arc will start becoming bigger as we go away from the wire towards the center. As we go away from the wire towards the center, in the center, here's the point. Here's the point, everybody. In the center, it gonna appear as a straight line, beautiful. So what I did explain you guys that the magnetic field gonna be a concentric circle in the circumference of the wire as it start going towards the center. As we start going towards the center, the arc will become bigger and bigger. We have a very great explanation of this topic in class. So the arc will start becoming bigger and bigger, and at the center it will appear as straight line. There you go, your answer. All right, all are satisfied. Write and yes in the comment box. Let me see. Write and yes in the comment box. Let me see. Everybody is getting me very clear. Am I audible? All good? All insulated? All are grabbing coffee on the other side? You should. Right. Sir, you can explain once again. Of course, I'll do, brother. So what happens here, you know, in a circular loop, all right, this is the pattern of a magnetic field. The current goes upside, and you can do it with the help of right hand thumb rule. Find out the magnetic field pattern, right? So there you go, there you go, there you go, there you go. Thumbs up, taste the thunder. You go, you just, after that, wrap it. Wrap it, wrap it. Thumbs up, wrap it. Thumbs down, wrap it. So when you do so, you will start getting the direction of magnetic field line. There you go. Right? So there you go. Thumbs up, there you have the direction. Thumbs up, thumbs down, there you have the direction. So understanding, right? There you have the complete direction. There you have the complete direction. Now the point is, what happens with this magnetic field line as it enters in the center of the circle? So you're gonna tell the arc will become bigger and bigger. At the center, it will appear as straight line. What is the arc I'm talking about? You see, guys, if I have to draw this, this is this bigger. If I have to complete this, this is this bigger. Right? So basically the arc is becoming bigger and bigger. At the center, it gonna appear as straight line. Am I very clear now? Am I very clear now? Yes, guys, please subscribe the channel, please. All right. Some people are asking to subscribe the channel. Subscribe, share with your friends, family. Seeing all the movies, Netflix, whatever. Stay tuned with Brilliant, guys. Stay tuned with Brilliant and subscribe the channel. Subscribe the channel, right? Subscribe the channel. All right, perfect. I guess everybody is learning. I can see the comments. It's really good. Subscribe the channel and then continue learning. So here you have the next one. Fuse wire is A. I should see my peoples. That is important. Otherwise, moye karte na tumka class mein. Trust me. So yes, I should see all the people. Otherwise, moye, you know this, right? So fuse wire is A. Fuse wire is A. Fuse wire is A. All right. Fuse wire is an alloy of what? What is the option over here? What is the option over here? What is the option over here? I need to have some fun, guys. I don't see no one on the other side. All I can see is a camera and your comment, right? So keep going. Moe is fine. All right. All right. Okay. Another meme. All right, everyone. Here you have fuse wire is A. Can you answer, please? Fuse wire is A. Moe is not the answer, brother. It's over. Fuse wire is A. All right. You guys study properly. Otherwise, in exam, paper will come out. Surprise, like that. Study properly. Paper will be giving you surprise. Paper have, exam paper will come out with hands like this. Surprise. With the new question. You don't know anything because you didn't study properly, right? So please study and stay tuned with us, right? All right, your answer is A. Your answer is A. Perfect. Your answer is a lead and tin. So I'm going to tell something like, do you know about this device? Do you know about this device, fuse wire? Do you know about this device? All right. So if you know, can somebody type in the chat box? Let me see where it is. Yes, paper gonna say moe for sure. Okay. All right. Can you guys type about this device? Can you, King of Physics? That's really nice one. All right. Can you guys tell me that, do you know about this device? If you know a little bit, can you explain in the chat box? Safety device, perfect. Safety device, perfect. What else more? What else more? Safety device for what? Help us to break the circuit, perfect. Gaming studio, come with your original name. Harsang Mehta probably. That's, I think, like that, but I'm not sure. All right. It's a safe device. It's a safety device, perfect, that protect us from unduly high amount of current. All right, I can explain it properly. This is your house in India. Don't take it in heart. I know you guys have big houses. Consider this is your house. Consider, right? Consider it's your farmhouse, right? So what happens after this? There are electric poles. We know as well. Very good, very good, very good. And a kind of wire comes inside our home. Right now, the first device where it enters is the electric fuse, which is protecting the other devices. So we know the domestic electric circuit, right? We know the domestic electric circuit. So when this wire comes, it's first going to encounter with this fuse wire, and then we have the other device, the electric meter distribution box. You remember, right? Distribution box, which distributes the current in different circuit inside our home, 15 ampere and 5 ampere rating. I guess you guys know this very, very clear. All right, lots of answers. That's really good. Really good, really good. Now I gonna ask you few questions based on this. So those people who lives in the apartment, often it happens like, if you are in a site like some flats, often it happens that all current goes off, right? Then this is uninvited person who comes after that, an uncle. All right, the uncle will be coming, and this uncle will have this stomach, no hairs, and will be wearing probably lungis. Do you have this uncle nearby in your home? What I am trying to explain, get me very properly, guys. If you guys are in the apartment, all right, and all of a sudden the current went off, and uncle comes, this is uninvited uncle. He gonna come with this and I know how to fix this. So he gonna come and will start fixing. He gonna open this, all right. So as soon as he opens, he's like, okay, iska to fuse gaya. The fuse wire is gone, right? That's how he will speak, right? So when this fuse wire is replaced, with other wire, the current comes back again. Once again, that uncle, if he don't know that he should use this material, what happens in the next time when unduly high amount of current comes in your home, all right, then it gonna burn everything. I will explain step by step why it is so. Okay, those who have got my joke, then it's fine. Those who have not got, please watch Pogo. All right, you know Pogo? Tom and Jerry you watch. So get properly. You need to have that good sense to understand me. All right, perfect. So Joule's law of heating. Heat is directly proportional to square of current. Seen somewhere? Heat is directly proportional to square of current. What does it mean? It means that if current increases, the heat will increase. Current increases, the heat will increase. So you are telling me in the comments that guys, that fuse protect us from unduly high current. How? See, say suppose unduly high current came, all right, in India, consider and this two wire got collide like that due to bad weather condition, or accidentally power high supply people has supplied a little bit more current. Accidentally, okay, it's not like willingly go current. It's not like that. So unwantedly they might have, accidentally they might have sent some amount of current, or the current came by own, not sent, came by own. So when it happens, the current increase, so square of current with current, this time it will bring heat also. Why so? Because according to Joule's law, heat is directly proportional to current. If the current is increasing, heat will also increase. And if the heat will increase, this fuse wire will melt. Understanding, everybody? This fuse wire will melt. And if the fuse wire is melt, current will not come to your home and your entire home is safe. That's what I'm telling. Now, when your fuse wire is melted, your home is safe, all current gone, right? That time the uncle appears. I stay away from that uncle. He don't know, because we need to use what? Lead and tin. He's gonna use here and there wires and fix it off. Next time what happens if more amount of current comes, means your home gonna be bursting. All right, everybody, you guys are getting me this clear. Are you guys are taking screenshot of these answers, or see repeatedly in YouTube? All right, after the live session gets over, it get repeatedly, repeats in the, it got stored, stays in the YouTube channel. You go back and see it and learn back. Otherwise, you tell whenever you take screenshot, I'm gonna do like this. All right, you are understanding. Which of the following is not attracted by magnet, guys? Which of the force is not which of the material is not attracted by a magnet? What should be your answer? I know legends will be making Control T, copied, and search, right? That's what you guys are doing for this answer. See, so gaming started laughing. I know you're gonna do that. What should be the answer, guys? What should be the answer? What should be the answer? Little bit of confusing. You have a chance of Googling, sir, on the other side. All right. B. Majorities are B. Majorities are B. What should be the answer? What should be the answer? That's not the answer. That's not the answer. That's not the answer. That's not the answer. All right. All right. I'm leaving it for you. I am leaving it for you such that you guys will search this question, understand, learn, and figure out which. I'm getting the answers now. I'm getting the answers. Yes, I'm getting the answers. You guys Googled, right? I'm answer in one side. Right. Perfect. All right. All right. Figure it out. What is non-magnetic material from here? I'm moving on to the next question, everybody. So please have a look on the question. What is the next one? Have a look on the question. What is the next one? I'm gonna drink some water. Yes, physics is going to die. We're gonna kill it. It's for sure. We're gonna kill Kalli Balli physics. We're gonna make it easy. All right. All right. What an energy. I got shawarma, brother. All right, everyone. There you have your question. A student learned that magnetic field strength around a bar magnet is different in every point. Which diagram shows the correct magnetic field lines around a bar magnet? So that's very, very clear. Very, very clear answer is B, right? Your answer is B. We know this. We know this. Every kids in this universe and the parallel universe as well, they know that this should be the figure. It starts from north to south. Internally, it starts from south to north. Perfect. Perfect. This comment should keep going. This is really good. I appreciate you guys for your effort. The magnetic field inside a straight current carrying solenoid. Magnetic field inside a straight current carrying solenoid is what answer? What will be the answer? What will be the answer? All right. What will be the answer? What Vishnu sir is real God. What will be the answer, everybody? What will be the answer, guys? You're gonna tell it's same at all the point. It's same at all the point, right? Why it is same at all the point? We have a small explanation which we did where somewhere here. I'm gonna show you once again. Somewhere we have did an explanation regarding this. That guys, inside the solenoid field line will be parallel straight, right? Where it is somewhere here, I just missed. All right, we can make it once again, no problem with it. We know this is the solenoid, and inside the solenoid, as we connect with plus end and negative end, the field line will be parallel straight, and that's how it goes, right? So inside it, right, answer is C. Answer is C. Perfectly all right. All right. All right. Here you go, the next question. I'm gonna take a pause a little bit. I'm gonna take a pause a little bit, and I want you guys to answer with reason. I want you guys to answer with a perfect reason of how this answer and why this answer is. Yes, I'm seeing the answer. That's perfectly all right. I'm seeing the answer. I need a small explanation of it as well on the chat box. Do some work, guys. Little bit of explanation. I know you on the other side, you are enjoying your life, sitting somewhere on home, of course. You guys need to do some little bit of work here. All right, Naira, Sharmila, Mridul, these guys are really good. Namira is here. Perfect. Vishnu sir, you are real energy. Yeah, you see this. All right, all right. Perfect. Love from Dubai. All right. Love from Qatar as well. All right, guys. You're gonna tell me that F is equals with BIL. BIL. The maximum value is B. No, see, let me explain this step by step. So we have this experiment, right, guys? Like we need to take a stand. We need to take a stand like that. There you have a stand, right? So this stand, you need to hang an aluminum rod. Do you remember this? Do you remember this? You need to hang an aluminum rod. I'm just trying to draw a very quick diagram and how it is. Like you need to add a battery and a cell and switch, and there you go. A very quick diagram I'm trying to make. So this is an aluminum rod, if you remember. So, and then you need to fix a horseshoe magnet in such a way the aluminum rod should lie between the poles of the magnet, right? Now, what happens next? You're gonna tell me that, sir, this aluminum rod will displaced. Hold on. You have this horseshoe magnet, there you go. Okay, you have this aluminum rod, there you go. Right? So now this aluminum rod is suspended freely, hanged, I mean, in a stand, right? So as soon as you bring this horseshoe magnet, what happens? You will tell, sir, it gonna displace. A force is generated. A force is generated. Understanding? It displaces, a force is generated. Now the question is, this force is maximum at what? Understanding? All right, in 90 degree, all right, in 90 degree, we're gonna discuss this formula in other way later. All right, the 90 degrees, those who are explaining sine 90 degree equals with 1, We're gonna explain it. Somebody is asking, sir, you explain again? Perfect, I'm gonna explain it again. So you have a horseshoe magnet experiment where we are figuring out force. To figure out force, what is your requirement? Your requirement is magnetic field and your requirement is current. So whenever you bring magnetic field and current in the vicinity, means surrounding, what generates? You're gonna tell force will generate. So see, this is unavoidable consequence in case of magnetism linked with current. All right, like if I run in the outside right now, I'm gonna sweat, right? I don't have a hold in it. Similarly, if you bring magnetic field and current closer with each other, if you bring magnetic field and current closer to each other, what gonna happen? You will tell it will start generating force. Understanding? Now the question is, the force on a current carrying conductor when placed perpendicular in uniform magnetic field, force will be maximum. All right, now we'll come back to this. We have a solid questions and we'll come back to this and we'll try to understand very properly. Or those who want an explanation, we can explain it right now here. F is equals with IBL, okay, IBL and then sine theta. All right, so if it is perpendicular in direction, suppose this is the magnetic field, this is the current direction. So if I switch it on here, current flows this way, right? So this is the current direction we have, and the magnetic field north to south, it is going upside like that. So this is the magnetic field. So when these values are perpendicular, what is the sine value? Is the greatest, right? How much is that? Sine 90 degree. Sine 90 degree will be 1. What is your answer? Your answer will be IBL, or simply you can arrange it this way, BIL. All right. Sine 90 degree is 1. Sine 90 degree is 1. So it is BIL. You guys are understanding, yes or no? You guys are understanding. So the maximum value will be F is equals with BIL. In the other word, the force produces depending upon the magnetic field. If you increase the magnetic field, the force will increase. If you increase the magnetic field, the force will increase. If you increase the magnetic field, the force will increase. Similarly, if you increase the current, the force will increase. So if you increase the current, the force will increase. And also if you increase the length, the force will increase. So this force is depend upon these three factors: magnetic field, current, and length. Also the angle between magnetic field and current. Direction. You guys are getting it? All right. All right. So let me see this question then. Let me see this question. Try to answer what exactly this question is. Help me out with the answer, please. Help me out with this answer, please. Help me out with this answer. The energy should not go down, guys. You should keep on commenting. I will definitely, reply on the comments. Please comment and see the answer. What should be the answer over here? What should be the answer over here? It is one of a very good question. What should be the answer, everybody? Most of are telling A, B. A and B is what is coming in the chat box. All right. Where are my peoples? I should see you people. All right, I can see everybody. Okay, let me try figuring out. See guys, this is the positive and this is the negative and what we know, current flows from positive terminal to the negative terminal. Current flows from the positive terminal to the negative terminal. Here you go, current is flowing P to Q. Current is flowing from P to Q. Current is flowing from P to Q. And this field denoted by B. This is the magnetic field direction denoted by B. Now they are asking, where will be this road move? Where will be the road move? The road will start moving towards the force. The road will start moving towards the force. Do you remember in the previous question? You have magnetic field, you have current. You have current, you have magnetic field. This was the direction for current and this is the direction for magnetic field. Here we have the current and magnetic field. What is generated? Our answer was force. Our answer was force. When is this force is maximum? When the angle between magnetic field and current is 90 degree. We have seen over here, right? It is maximum and this is the value over here. Clear? Now similarly, since it is generating a force, guys, since it is generating a force, the road should move towards the force. Now the question is, which side it will move? Bata do. Which side it will move? Which side it will move? Just put your middle finger towards this side. This is current. Understanding? This is current. This is current. Can you see? This is the magnetic field going up. This is the magnetic field going up. Current, magnetic field, current, magnetic field. Thumb, it is showing outward, right? Out of the field, out of the field. If you remember Fleming's left-hand rule, if you remember, stretch your fingers in such a way, if middle finger shows the direction of current, first finger shows the direction of field, then thumb shows the direction of force. You remember, right? So I need to figure out the direction of force. That's it. To figure out the direction of force, just align the finger accordingly. 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 There you go. I'm aligning it. This is the direction for current. Middle finger towards the current. Middle finger towards the current. Do it in your screen, everybody. And this is the magnetic field. And you will see thumb is pointing outward. There you go. This is your answer. Very good looking question. Yes. Where everybody's are here. Yes, yes. Where all the people are here. You guys are Sigma and Alpha peoples, right? You need to be here. All legends are here today. Correct? I need all legend people here who is studying physics in this late night. All right. Perfect. Perfect. Now let me see the next one. A soft iron bar is introduced inside a current carrying solenoid. A soft iron bar is introduced in a current carrying solenoid. The magnetic field inside a solenoid is. And to figure out the magnetic field inside a solenoid. What is the magnetic field inside a solenoid will be? Can you guys write the answer? Can you guys write the answer? Yep, Yug is here. I can see Finin, Mridul. All right. Let me call your names. All right. Put some fires as well. All right. See properly. See properly. See properly here. A soft iron bar is introduced inside a current carrying solenoid. The magnetic field line inside a solenoid will be. See guys, we know while making electromagnet, we're gonna wrap wires above a non-conducting material like that. And you have this, right? Positive and negative terminal, right? And what you will fix inside, let me fix a soft iron. There you go. You have fixed a soft iron inside. Now what will happen, they're asking, if you place a soft iron inside, what's gonna happen? You will tell it will increase, right? Our answer is it will increase. Now you'll ask me, sir, why it is increase? I'm gonna tell you that soft iron has a property of magnetizing and demagnetizing very fast. Magnetizing and demagnetizing very fast. So what I mean over here, electromagnet depends upon nature of material, right? It depends upon nature of material. So as soon as you put a soft iron inside, it gonna add the magnetism. Get me very properly. It gonna add the magnetism of the solenoid. It gonna add the magnetism of the solenoid. It will increase. Perfect. Now, how about this question? How about this question? We're gonna go very fast. All right. Those who didn't got a simple thing, or I might have missed something, if I'm gonna try replying in the YouTube chat box. All right. We're gonna go fast. I have 25 questions. Let me not leave one also. Right. We're gonna do everything properly. All right. What will be the one? What will be the one? What will be out? What will be the answer over here? Let me. Yes. Yes. What gonna be the answer? The energy is going down, everybody. I can't see the chats much now. The energy is going down. It should be like the beginning. It should be like the beginning. We have 15 minutes more to go. It should be like beginning. All right. The question is, for a current in a straight long solenoid, North Pole and South Pole are created at the two ends. So they are telling that when you put a solenoid, right? When we have a solenoid, once you fix with a, circuit, what's gonna happen? It will basically generate two ends over here. So one of the end, let's say it is North Pole, and one of the end, let's say it is South Pole, which you have learned it like that. A current carrying solenoid behaves like a bar magnet. How? Because one end of a solenoid behaves as a magnetic North Pole and other end behave as a magnetic South Pole. And how you gonna check it? You will simply take a bar magnet closer to it. So if you take the North Pole of the bar magnet, say I'm taking this side, right? If this North Pole is getting attracted, you're gonna tell that it is South. If it is getting repelled, this will be North Pole. All right. Now we know how the field line looks like. You will tell start from north ends in south. So start from north and ends in south. Right. So we know it is starting from north ends in south. Starts from north ends in south. Internally, you're gonna tell, sir, it will start with from south and ends in north. Though it's a close and continuous curve. So there you go, there you are. So ain't it similar as a bar magnet? Ain't it similar as a bar magnet? Tell me yes or no. You're gonna tell yes, sir. This solenoid field sees exactly the solenoid sees exactly like the magnetic field of a bar magnet. All right, so the magnetic field line inside a solenoid is in a form of straight line, which indicates the magnetic field is same at all the points. This is correct. For a current in a circuit solenoid, north pole and south pole are created at the two end. Among the following statement, the incorrect statement I need to figure out. So see, when I was telling you that this part should be the correct answer, and this is wrong as well, incorrect statement. The pattern of magnetic field associated with the solenoid is different in the pattern of magnetic field around the bar magnet. I'm highlighting the key, okay, understand properly. So they are telling the pattern of magnetic field, the magnetic field pattern of solenoid. The magnetic field pattern of solenoid is different from the pattern of magnetic field of a bar magnet. Is it correct? Yes, it is the incorrect statement, right? It is the incorrect statement. Perfect. Perfect. There you go. The pattern of magnetic field line associated with the solenoid is different from the pattern of magnetic field line. And this is the correct statement. Let me see the next correct statement. So that's how you will learn MCQ, all right? Not only you figure out the wrong statement, please do figure out the correct in this type of. Here you are understanding concept, guys. Let's see the second one. The strong magnetic field produced inside a solenoid can be used to magnetize a piece of magnetic field material like soft iron. So guys, this is somewhere the definition of electromagnet, right? Perfect. The north pole and the south pole exchange the position when the direction of the current through the solenoid is reversed. So when you interchange this terminal of the battery, right? When you interchange the terminal of the battery like that, what's gonna happen? The north pole will come this side, south pole will go this side. So all the other three statements are correct, which is not correct. Which is not correct? You're gonna tell me the C is not correct. Am I going good? Everybody is understanding. Everybody is understanding. I love the comments you people are putting in the chat box. This is really exciting me a lot. All right. Appliances that have a metal body are generally connected to earthing wire. What is the reason to this wire? Little bit of sick, but the show must go on. All right. Pardon me. All right. What should be the answer? What should be the answer? I am really loving your comments. That's really good. Thanks. So appliances that have a metal body are generally connected to the earthing wire. What is the reason? So we know the answer will be to prevent the leakage of current. Guys, you often get electric shock while you touch a metallic body, right? Say fridge. Sometime when you touch fridge, you get a very mild amount of an electric shock, very little, right? And then you will like start discussing to your family like, hey, see here, I'm getting an electric shock. Sometimes it happens with, electric irons and all. I mean to say, wherever you have a metallic body, sometimes, very rare cases, all right, nowadays very high quality machines, you don't get electric shock on the body of the machine I'm talking about, all right? So when you get this electric shock, it get leakage. And you're gonna tell me why it is leakage. Say for example, this is the machine. If I touch this, I'm getting a mild amount of electric shock over here. Why it might happen? Inside the machine, there might be small wires, right? Which have a light PVC coating. And what we know about current, wherever current is there, there will be heat produced. Yes or no? Whenever current is there, there will be heat produced. Now, with course of time, as you keep on using this machine for a long time, what might happen, the inside wire might get damaged and the PVC coating may open. So when this coating will open, it will start getting leakage of current in the metallic body. We know metal provides low resistance path, right? Metal provides low resistance path. If I'm a little bit of fast, pardon me, all right? Keep on repeating, seeing the YouTube, it's gonna be there. You will definitely understand. There is nothing rocket science. So when this body will start getting the currents due to the PVC damage of the PVC coating inside the wire, when you touch this, you will start getting electric shock. And therefore, we are using earthing. We are using earthing. All right. What is the reason of earth wire? So it will take the leakage of current into the earth, making the user safe. So I'm gonna tell you how it is happening. So once this metallic body is connected with the earth wire, the leak amount of current will start flowing like that. Where? To the earth wire. All right, inside the earth wire. Suppose this is the machine, all right, and you connected with an earth wire. So whatever the leak amount of current is over here, it will start flowing this way and it will go inside the earth where a metal is buried, and this system is called earthing. I guess everybody know it. You guys are getting me clear? You guys are getting me clear? You guys are getting me clear? Tell me yes in the chat box, please. Tell me yes in the chat box, please. You guys are getting me. Okay, so some fires. That is really good. All right, so some energies. All right, I should inherit your energies from other side. All right, yes, perfect. Tarini is there, Ankita is there. I can see my peoples. Atmana is there. That's really good. Karthik. All right. All right, now which way does the wire in the diagram below tends to move? All right, I can see everybody is here. This is really good. That's really good. That's really good. Perfect. Perfect. Now try answering this answer. Try answering this question, I mean. Try answering this question. Thank you, Taigun. All right. Try answering this question, please. What should be the one? Which way does the wire in the diagram below moves? Once again, you need to figure out force, guys. Once again, you need to figure out force. The thumb. Once again, you need to figure out force. The thumb. Apply the rule. Apply the rule. Once again, you need to figure out the thumb. Everybody, apply the rule. Apply the rule. Apply the rule. All right. Apply the rule. Are you getting the answer? Many of you are D and A. B as a mix-up. So you guys are not clear with such questions, right? All right. Padma Varshan is telling A. Okay. I can read the names. Sharmila is telling B. All right. A and B. Right now it is A and B. A and B. A and B. How about C and D, guys? Gaming Studio B. All right. Ankita Nair B. All right. Perfect. Okay. Okay. So see properly, guys. All right. All right, guys. Middle finger in the direction of current. Can you see this? Middle finger in the direction of current. Middle finger is the direction of current. Can you see this? Middle finger is the direction of current. Which side magnetic field? North to south. It will be downward, right, guys? Magnetic field. Middle finger on the direction of current. Magnetic field. Magnetic field. Where the thumb is pointing. The thumb is pointing downward direction into the page. Please do it. Please do it once. You should know how to solve such questions. All right. You should know how to solve such question. You got me. This is the direction. I write in middle finger. You can write I. FBI, Federal Bureau of Investigation, right? FBI. So F force, B magnetic field, I current, right? So when you do this, so this is the direction for current, and there you go, magnetic field downward. So you keeping the middle finger in the direction of current. You can't shake it, all right? So there you are. There you go. Right? Thumb is pointing inward. Visible? This is the direction for current. This is the direction for magnetic field. And here you see the thumb is pointing into the board. Am I clear? Am I clear? Am I clear? Yes, guys. Today I'm going to nail it for sure. All right. Am I clear to everyone? Yes. Am I clear to everyone? All right, perfect. अच्छा काट दो इसको, गलती से mistake हो गया. So you can cut this, no problem. So this is the correct answer. This is clear, right? Right? All right. Perfect. 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 So here you have the next one. Here you have the next one. Try to answer with an explanation. Try to answer with an explanation. Try to answer with an explanation. Somebody, I didn't understand. All right, let me come back to it. All right, let me come back to it. It's very simple, guys. You need to point this middle finger towards this direction. You did, I guess, right? Okay. Then magnetic field, north to south. This is magnetic field. B stands for magnetic field. This is the current direction. So current, okay, current, magnetic field is downward. So roll it like this, downward. Take a screenshot. Right? There you go. Simple. Thumb is pointing inside. Do it. Little bit of hard work, guys. All right, I guess you are getting it. Repeat it. See repeatedly, you're gonna see it. Okay, all right, Nesha, you got it. That's fine. Okay, now see this. No force act on a current carrying conductor when it is placed. So you have this case, right? You have this case that say this was the magnetic field, a horseshoe magnet north and south, and you have the aluminum rod which was carrying current. You have this aluminum rod which was carrying current. You have this aluminum rod A and B which was carrying current. So this is the current, this is the magnetic field, right? This is the current direction. This is the current direction. Magnetic field is north to south going upward. Understanding? And we know if it happens, so you will tell, sir, it's gonna produce a force. It's gonna generate a force, proper term. It's gonna generate a force. Now the question is, no force act on a current carrying conductor. When this current carrying conductor, there will be no force. If somehow, if you make this direction, right now this direction is perpendicular with each other, and we know it's gonna be maximum. Now they're telling if it is parallel, say current is going this side, and very close to it, like that. One soap over another soap, right? Very close to it. So when it happens, this is the direction for magnetic field. In this case, there will be no force generated. There will be no force generated. This is your answer. Parallel to the magnetic field, there will be no force generated. This is the answer. This is the answer. There will be no field generated. Why it is so? Why it is so? I'm focused in the comment box, everybody. Why it is so? I'm focused in the comment box. I should see it. I should see it. I should see it. Sine 0 degree, right? What happens if it is sine 0 degree? All right. Somebody is telling, okay, let me write the formula. F is equals with ILB sine theta. So ILB sine, what is the angle between them? You're going to tell me 0 degree, right? So sine 0 degree is how much? Right, sine 0 degree is 0. Perfect. Sine 0 degree is 0. So entire value when you multiply with 0, your result is 0 here. That's it. Beautiful. So understand it very, 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 very clear. All right. Understand it very, very clear. We have a formula over here to find out the force. It depends upon current, length, and magnetic field. Length of the conductor, if you increase, force will increase. If you increase the current, force will increase. Magnetic field, if you increase, force will increase. Also, it depends upon the angle between the direction of current and direction of magnetic field. It depends between the angle in the direction of current and direction of magnetic field. Get this point. In this case, it will be maximum. When it is parallel, okay, you will apply this formula, ILB sine theta, right? Theta is how many degree? You're going to tell 0, right? So sine 0 degree is 0. When you solve all this answer, if you multiply with 0, your result will be 0, right? Everything is 0. Perfect. In one word, everything is 0. You guys are getting it. Am I clear? Tell and write and yes over here. The comments are a little bit of delay. I'm going to take a pause to see whether you did understood or not. Write and yes over here if you did. Help me, guys. 2 more minutes we have. We're going to figure out all the solution answers. 2 more questions we have. 2 minutes, 2 questions. 2 minutes, 2 questions. Can we do it? Can we do it? 2 minutes, 2 questions. Can we do it? Yes. Show some energy, show some fire in the comment box, please. I should see you people helping me on the other side. All we need is an help, right? All right. All right. All right. Which of the following determines the direction of magnetic field due to a current carrying conductor? Which of the following determines the direction of magnetic field due to a current carrying conductor? Which rule? Which rule? Which rule? Which rule, guys? Which rule? Which rule, everybody? Which rule, everybody? Which should be the answer? All right, you're gonna tell me Maxwell corkscrew rule, right? So you have seen this, you have seen this, you have seen this. Have you seen? So if you drive the screw in the direction of current, get my point, get my wording clearly what I'm speaking. If you drive the screw in the direction of current, if you drive the screw in the direction of current, how you drive the screw? There you go, there you go, there you go. In wall, you will put it like this, right? Right? In wall, okay, I should show you like this. So that's the wall, you are driving it like that. When you open it, you are driving it like that. There you go, right? Perfect. You're not getting it? I'll come a little bit of closer. There you go. You see, right? Right? So when you drive car, no, you drive screw also. You guys are driving me crazy right now. All right, everyone. So when you are driving a screw in the direction of current, what gonna happen? If the screw will rotate in the direction of magnetic field. There you go. Am I clear? Am I clear? Am I clear? Everybody is getting me? All right. All right. Perfect. 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 Your final question. Your final question to end up the session. Your final question to end up the session. All right. Overload due to short circuiting. Overloading happens due to short circuiting. What happens when live and neutral comes in direct contact? The current will increase abruptly. Very simple. Live and neutral comes in direct contact. The current will increase abruptly. When the current increases, we call it overloading. All right. All right. So this is the first one. And second, it will increase in the power supply. So this is your answer. Option D is your answer. All right, everybody, I'm getting the warning sign from the technician that you need to stop. And I will stop right now, and I'm gonna see you yet another beautiful lesson in physics. Stay tuned, study with us, and do share this video. Subscribe the channel, click the bell icon, do whatever you want. Stay in peace. I'll see you next time.
Hi everyone, welcome to
Amazing channel of Brilliant Qatar.
When you're rubbing one body with another body, electrons are transferred from one object to what? Another object. Okay, this process, this type of electricity is been given a name.
halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartless fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Brilliant Qatar.